Welcome to video 4.2. This is the first of 3 videos on nomenclature. Nomenclature is just a fancy word for how we name chemical compounds or name molecules. And so today you're going to look at the first way we name compounds, specifically ionic compounds, and we're just going to call it the type 1 way. So in this video, you're going to learn how to write the chemical formula. You're going to be able to explain how the charges on each ion will determine the chemical formula, and then you're going to be able to name those chemicals, or from the formula be able to name them, or if I give you the name, write out the chemical formula. So as we get started, here's a few key vocabulary terms: chemical formula, subscript, monoatomic ion, nomenclature, and polyatomic ion. As we get started, you will also need your periodic table. You'll also want the polyatomic ion paper I gave you in class, or you can find Google Classroom for when we do those practice videos. So as we get started though, what is a chemical formula? A chemical formula is just how we will write, using the symbols and a subscript, the chemical that we're talking about. So here an example, this 2 is what we call a subscript. If it was up here, it would be called a superscript, but the 2 is down here. And all it shows that there are 2 hydrogens. And then since there's no number here, we assume it's a 1. And so there's 2 hydrogens to 1 oxygen in every water compound. And this is actually covalently bonded, so we can actually call this a molecule. But for right now, a chemical formula is just when we do symbols and subscripts. So as we get started, and we're talking about ionic compounds, we have to understand what our ions are. Ions are broken into 2 different categories. We have monatomic ions and we have polyatomic ions. Monatomic, mono means 1, means a single atom. And in a little bit in this video, you'll see polyatomic ions, where it's just many atoms brought together to make an ion. So here are examples of monatomic ions, individual elements that turn into an ion, and they're just floating around with the charges. Again, make sure you understand that when we have something like Mg2+, that 2+ is telling us that this Mg, this magnesium, has a +2 charge. What does that mean? Well, from last unit, you should remember that that meant it lost 2 electrons. Since it lost 2 negative electrons, it got a +2 charge because, again, it wants to obey the octet rule. And this is, again, a stable form for it to run around with this charge. The opposite of that is our anion. So remember, Mg2+ is an example of a cation, a positive charge ion. Fluorine negative is an anion. It indicates that fluorine gained an electron to become stable, to obey the octet rule. And so that negative charge here means that fluorine, it's not fluorine anymore, but it's actually called fluoride now with that negative charge. And that's what we're looking at. So how do you determine your charges? Again, we are looking at them based upon the periodic table. And so looking at the periodic table I gave you, you should again recognize that the families that they're in, and based upon their families, will give you the types of charges they have. So our alkaline metals will have a +1, our alkaline earth metals have a +2, our noble gases are neutral, so they won't be making chemical compounds. But then we have our halogens, and then of course the oxygen family, nitrogen family, and a couple other metals down here. The other way to look for their charges is, again, if you look at the periodic table, you look at the bottom, you look for oxidation states. That also tells you the charges that they will form. So for the purpose of type 1, we're just going to be dealing with the group 1 and group 2, and then a few other metal compounds. Specifically, what we're dealing with in type 1 are just ions that have just 1 single charge. So the first 2 groups are definitely going to be either a +1 or +2 charge. And then these are a few transition metals that have just 1 charge that they form. So again, for type 1, we're just using ions that have specifically 1 charge. So again, what we're talking about is nomenclature. Nomenclature is just a way we name. It's a fancy term for how we name compounds. There's going to be 3 types. This first type is the first way we're going to do ionic compounds. Remember, ionic compounds are when things that are negative or nonmetal will bond with things that are positive or metals. So our negative ions, our anions, will bond with our cations here. And that's what we're going to do right here, is look at how to name ionic compounds and how to write chemical formulas for ionic compounds. So it's really simple. I got 3 easy steps here to show you how this works out. So the first step you want to do in writing out an ionic compound is, and that's after you determine it's an ionic compound, after you determine it's something from the right side of the periodic table bonding with something on the left side of the periodic table. First thing you want to do is just want to write out those symbols. After you write out those symbols, look at your periodic table to determine what kind of charge you're going to have. So again, to show you what this looks like, here's my periodic table. We're dealing with magnesium, and we're dealing with chloride. Chloride is right here. Chloride is a halogen, and so we should recognize that he's going to gain just one electron to become stable. So chlorine's going to have a -1 charge here. We look at magnesium. Magnesium's in the second family, and here you can see magnesium actually only forms a +2 charge, so he has to be a +2. So we're going to take magnesium and chlorine. Once we determine and found their charges on the periodic table, we can include those up in the top right corner in the superscript to make them the ions. And then now what we're going to do is we're just going to do this cross idea. We're going to cross the absolute value of your charges. So simply, because there's a +2 here, we're going to put the absolute value down here. So you can see that +2, we're just going to put a 2 down on the chlorine. So we're going to take that number and put it there. Chlorine has a -1 charge, so we're going to take the absolute value of that, which is just 1, and we'll put that 1 behind magnesium. The whole goal of this is to get the charges to balance out, to total up to 0. So what we're doing here to come up with this correct chemical compound or this correct chemical formula, I have to have 2 negative charges on my chlorine to balance out with the 1 + 2 charge on magnesium. So pretty simple. Write down the symbols with their charges, and then cross the absolute value. 2 plus puts a 2 here, -1 puts a 1 here. When we're doing this, make sure you do leave these subscripts down here in the lowest common number, and I'll show you what that means as we do our practice. So here we go. Let's look at some practice here. If you want and you feel comfortable, pause the video. If you don't feel comfortable, watch me do the first one. Then you can pause the video and try this yourself. So the first one here, write the formula for the following compounds. We have magnesium sulfide. So my first job I told you to do is just simply write down their symbol. So if I look at my periodic table, I see magnesium is Mg, I see sulfide is S, so that's MgS is what I'm going to do. Now real quick, why is this sulfide and why is this sulfur? In the next few slides, you're going to realize that's how we name them. Whenever we name these elements, when they're in ion form, we're going to change the ending to IDE. You'll see that in a second. So sulfide is when sulfur has that -2 charge. How did I come up with sulfur as -2? Because he's in the oxygen family, he's going to gain 2 electrons to have a charge. If this helps you, feel free to write down -1, -2, -3 here, and then feel free over here to write plus or -4, +3, +2, and of course +1, if that helps you. But how do I know sulfur is -2? Because it's in the oxygen family. How do I know magnesium is a +2? Because it says it right there, and it's in the alkali earth metals. So here. So now step 2 is just cross the numbers, cross the absolute value. So that 2 gets moved down here. That 2 gets moved down here. And so you're going to get something like MgS. Now, why did I just write MgS? Why did I only put a 1 and a 1 here? Because, again, we want to write this in the lowest common number, so we want to make sure it's in like the lowest terms. So since it's a 2-to-2 ratio, we're just going to reduce that to a 1-to-1, and this would be our answer. All right, so the next one. Go ahead and for you guys, pause the video, try it yourself, and then when you're done, watch how I do it with my own hands. All right, welcome back. Aluminum bromide. What am I going to do? I'm going to write down the symbols. Again, aluminum, Al, bromine, Br. Now I'm going to include their charges, -1, +3. So bromine is going to be a -1, aluminum is a +3. Do that idea of just crossing the absolute value, and then rewrite your answer to give me the correct chemical formula that's all nice and polished. Again, I don't need to write the 1 because we're lazy, and so if I don't have to, I don't need to. We don't write a 1. It's already assumed that there's just 1 aluminum, but I do need the 3 down here, and that would be my answer for aluminum bromide. Again, as you can see, this is all pretty straightforward. Okay, sodium nitride. How do I know what sodium is? Sodium is right here. How do I know what nitride is? Nitride is just nitrogen when it's in ion form. Again, nitrogen, nitride, oxygen, oxide, sulfur, sulfide. nitrogen, oxygen, sulfur are the element names. Nitride, oxide, sulfide are the ion name or the anion name. The charge, nitrogen has a -3. Sodium has a +1. Cross those values. So I get a 1 and a 3, and then clean it up, and a 3, and nitrogen. After you do your homework, I suspect that this should all be first nature to you. But on your homework, I do want to see this work shown more or less so you could perfect it. But again, this is all pretty straightforward. All right, so now we move forward. Now let's go the other way. Let's practice naming. So if I give you the chemical formula, can you give me the correct name? Or if I tell you, if I give you the chemical formula, can you tell me the correct name? So how do we do this? Well, first of all, we're going to identify the elements that are present in the compound, but then we're going to use their ion name to name them. When you have a monatomic ion, they're very simple and very easy to name. When it's a monatomic ion, if it's a positive charge, you just simply say the element name and you add the word ion to the end. So how do I name the sodium ion? I just say the sodium ion. Potassium ion, silver ion, copper ion, magnesium ion, calcium ion. So monatomic naming is very simple if it's positive charge. If it's a cation, it's just the name of the element and you add the word ion. When it's negatively charged, it's again very simple, but all you do is change the ending to IDE. So instead of fluorine, it's fluoride. Chlorine, chloride. Bromine, bromide. Oxygen, oxide. Sulfur, sulfide. Nitrogen, nitride. Phosphor, phosphide. So it's, again, straightforward. IDE gets added down here. Here you just add the word ion, and then we move on with our lives. So again, identify the elements present, use their naming from their ions, and just stick them together. So again, step 2, use the cation name, which would just be the magnesium ion. We drop the word ion, and then we add the phrase IDE to the trunk, so we get chloride. So again, magnesium, chloride. Let's practice. Again, if you want to watch me do the first one, you can. If not, go ahead and pause the video and try these yourself to get this down. All right, welcome back. How do I name these? Again, I'm going to just name the cation, name the anion, and stick them together. What is Ag? Ag is just simply silver. So it's the silver ion. We just remove the phrase ion. We have chlorine. It's not chlorine anymore, but since it's an ion, we call it the chloride. So it's just simply going to be silver chloride. That is going to be 2 words there. But all I did was just change the ending from chlorine to chloride, and I just named the cation, which is basically silver. So it's a silver element, or it's a silver ion. We're just going to say silver chloride. Look at the next one, CaO. Ca is calcium. O is oxygen. Change the ending. So it's very simple, calcium oxide. Quite easy, right? Last one. How do I name this? Al stands for aluminum. Sulfur is S, but when it's an ion form, we're going to call it sulfide. So how do I name this? Aluminum sulfide. Easy, right? All right, so as we're moving along here, now we have to learn how to name what's called polyatomic ions. Polyatomic ions is this idea here that sometimes multiple atoms will bond together covalently to create an overall ionic compound. That ionic compound has a charge, an overall ion, and that ion can come together with another cation to form a compound. So don't get too stressed out about this. Traditionally, I've had my kids memorize all these, but this year we're going to try to see how it goes without you guys memorizing them. So in class, you should have picked up this sheet. And when you have this sheet in class, we're going to take time to cut it out and attach it to your periodic table. But all your polyatomic ions are listed right here. So what is a polyatomic ion? It's just simply when multiple atoms, many atoms come together and they form an ion. These are really easy to name because all you do is just take the name that's given and include it in the compound. So instead of changing the ending, we just use the name given. These are almost always anions. You actually have just one positive charged cation here, which is ammonium, NH4. So again, these guys will act as a single atom or a single ion, and we're going to follow the same naming rule. So again, this is pretty straightforward. All you have to do is be able to look at your sheet here and get the name for the anion. So we're going to do what we did before. Name your cation, name your anion. So here's some practice. Write out the formulas for the following compounds: aluminum sulfate, barium nitrate, sodium phosphate. I'll show you the example with my own hand, and then you can pause it and do the last two yourself. So as we get started here, here's the paper. So again, in class, you should have picked up one of these. If not, you can find them on Google Classroom. But what you're going to do with that is we're going to actually cut it out and attach it to the alongside your periodic table. So you have all your polyatomic ions readily available. These guys are very common. These guys happen all the time, so we want to have those as common as our elements are, or as accessible as our elements are. So again, naming them pretty simple. Aluminum sulfate. How am I going to write out this chemical formula? Okay, so first we're going to write out the ion for aluminum. We got the name off the periodic table. Look at my periodic table. I see aluminum has a +3 charge. Now I want to write out what sulfate is. So as I look on my sheet that was given to me, I see that sulfate is SO4 with a -2 charge. Notice the parentheses. You want to keep those parentheses there. So we're going to write down SO4 with a -2 charge. And then we're going to do what we did before. We're just going to cross the charges, the absolute value of the charges. So that 3 goes here. That -2 will go here as 2. Then we're going to rewrite it to give Mr. Lawrence the correct answer. Now, why do I need this parentheses here? Because this SO4 is a single ion. He is a compound within a compound. He sticks together, and that -2 refers to the charge of that whole little compound there. So when I put a 3 here, I have to triple the amount of SO4s there are. So you need to leave the parentheses there if there's a subscript present for that. And you'll see an example of that here in a second. All right, pause the video, try the next two, and then turn it back on when you're ready to check the answer. Okay, welcome back. Barium nitrate. Barium is Ba. Barium has a +2 charge. We have nitrate. So again, I am looking on the wonderful gift that Mr. Lawrence gave me. Nitrate, notice it is NO3 in the parentheses with a -1 charge. NO3 in parentheses with a -1 charge. I just cross out the absolute values and then rewrite the answer, cleaning it up. I don't need that 1 there. I keep my parentheses there. And then I need 2 of those. Last one, sodium phosphate. Sodium plus phosphate is a P right here. PO4 with a -3 charge. PO4 with a -3 charge. Now again, we just cross the absolute values. 3, 1. Now I rewrite it, clean it up. Na3. Now here's a case where you don't need to include the parentheses because there's only a subscript of 1 here. So again, we're lazy. We don't need to write those extra parentheses there in this case because there's only a subscript of 1. If you want to leave the parentheses there to make yourself feel better, I don't care. You'll clean it up as you go. But really, the parentheses have to be there when you have a subscript on your polyatomic ion. All right, now let's go back the other way. Let's name these bad boys. Again, we're just going to name the cation, which is just the element name, and we're going to name the anion, which all these are polyatomic ions. So I already gave you the name on the paper. So the first one, SR, stands for strontium. Strontium. And then NO3, I got to find it on here. NO3 is called nitrate. So this is just simply strontium nitrate. Go ahead and pause the video. Try the last 2 by yourself. Welcome back. Ca is calcium. SO4, find it on here. SO4 right there. Sulfate. Calcium sulfate. Yes, it is that easy. Last one, Na is sodium. OH, looking on here, I find OH. Hydroxide. So this is just simply sodium hydroxide. There we go. All right. So a few tips here. Remember, when we're naming and when we're writing these formulas out, make sure you're able to identify your ions. Identify whether it's a cation, identify whether it's an anion. Again, that goes back to the periodic table, but just identify what the ion is first, its charge and its name. When you go to write these chemicals out, again, we're always going to put the cation first. So this right here correctly would be written as sodium bromide, NaBr. You don't ever put the anion first. So again, cations are always written first or described first. Remember, when you use a polyatomic ion, the subscripts within the parentheses or the polyatomic ion itself does not change. Treat those as its own individual ion. And don't skip the steps. Even though you think you got this down, use the absolute value, use the crossing number idea. Don't skip any steps until you're really perfected it, and you won't really perfect this until after you perfect it on the test. So don't skip steps. All right. Long story short, we have certain rules we do in naming compounds. When we go to name them, we're just going to name our cations and our anions and stick them together. When we identify our charges and we cross those absolute values, it gives us our subscripts on the chemical formula. And again, a polyatomic ion is just simply an ion that has multiple atoms. A monatomic ion is an ion with just one atom. I hope this was a good video for you. I'm trying to keep it short. Have a great day.